this evening. This is truly a wonderful event, and I want to thank, first of all of the organizers who have made this possible. I personally witnessed the great work of both Dr. Bob Prezant and Dr. Janan Jabab, and I want to thank them now. And I also want to thank two of my students who are here tonight, Franco and Amy. There are a number of mysteries unresolved in terms of the brain. The hard problem of consciousness, the argument over whether free will actually exists, or how the brain creates emotions. The questions posed this evening surround and address an equally compelling mystery: how the brain makes possible creativity and original processes. Starting with the enigma of novel cognitive dynamics and how the brain constructs unique thought, to the blacksmith and the artist, we will hear about creativity and its neural origins. At a basic ultimate level, without creativity, there would be no science, there would be no art, there would be no culture. As such, the evolutionary pressures certainly have placed a premium on a brain that is creative. But we do know that creativity comes at some cost. There are times when creativity gets us in trouble, and we develop technologies that we may not be ready for. But at its core, at its very basis, we are going to hear this evening about the brain and a question that many of us have posed listening to a great piece of music or seeing a great piece of art. And that question is, wow, how did someone do that? How did someone think of it? We all know in academia that the investigator often studies the topic that embodies that very same researcher. The neurotic clinical psychologist studies anxiety. The riddled English professor is a Dostoevsky expert. The unusually fit physical education doctor is a highly regarded expert of diet and nutrition. Tonight is no exception. In the field of neuroscience, there is no single person more creative than Dr. Nancy Andreasen. Her originality and major discoveries have shifted the field of neuroscience countless times. She is known as the foremost expert on schizophrenia and the brain. However, she is also a pioneer of neurogenetic imaging, being the first to link specific polymorphisms to the brain. She is also the founder and the first major proponent of a full spectrum view of mental disorders. She has also examined and been the first to include the brain, the behavior, and the genetics in a comprehensive use within both psychology, psychiatry, and the medical sciences. Therefore, when we heard many years ago that Nancy Andreasen was delving into the field of creativity researcher, no one was surprised. It is a creative person, probably the most creative person in neuroscience who is studying creative processes. Dr. Andreasen is easily, aptly, and accurately described as a Renaissance woman. Thus, should we be surprised to discover that her first doctorate degree was in English Lit, focused on the Renaissance period. She won a Fulbright scholarship and was in fact an accomplished scholar in English before receiving her medical degree, commencing her pioneering work in the 1970s. In the past 4 decades, she has been among the first to employ twin studies, neuroimaging, and loci examinations, all fields that currently dominate neuroscience. A Nebraskan, she embodies hard work and commitment, personal triumph, overcoming personal tragedy. Her accomplishments and awards are too many to list. And when someone wins the Academy Award, you don't talk about community theater. And I will not list her community theater, I will only tell you about her Academy Award, which in the year 2000, she won the most prestigious science award one can win in the United States, the National Medal of Science. And she got to meet a fairly elected president, Bill Clinton, which is quite sorry, had to throw that in. Now you know that it's really me up here. She holds the Andrew H. Woods Chair of Psychiatry at the University of Iowa, Roy J. and Lucille A. Carver College of Medicine. And I will say on a personal note that back in 1995, reading one of her papers and presenting it to my own doctoral dissertation advisor, convinced him that it was in fact possible to study self and the brain. So it's a real personal treat to have her here tonight as well. And I'm nervous, and you know it takes a really smart person to make me nervous, and I'm scared to death. It is my absolute pleasure to introduce tonight's Sokol lecture speaker, Dr. Nancy Coover-Andreasen.
Well, thank you, Julian, and it's a real pleasure to be here, and it's a great pleasure to be giving this talk after the talk that you just heard, which I thought was a wonderful unification of art and science. I'm going to be talking about creativity, as promised, and I'm going to begin the talk with a bit of music, and the music has a point to it. It's Don McLean's Starry, Starry Night, for those of you who are familiar with it. And you'll see, while that music is being played, images of some very great people who suffered from mental illness. And this is to make you aware that there is sometimes, but not always, a link between creativity and mental illness. And I have to say this, speaking as a psychiatrist, because a lot of my career has been devoted, A, to eliminating stigma, and B, to trying to help people who suffer from mental illness. So the presentation is to help expand your minds to become understanding of the people who suffer from these diseases and realize that lots and lots of gifted people have suffered from them. It's not a terrible thing. So it begins with the motto of the National Alliance for the Mentally Ill: people with mental illness enrich our lives.
Starry, starry night, flaming flowers that brightly blaze, swirling clouds in violet haze, reflecting Vincent's eyes of china blue, colors changing hue. Morning fields of amber grain, weathered faces lined in pain, are soothed beneath the artist's loving hand. Now I understand what you tried to say to me, and how you suffered for your sanity, and how you tried to set them free. They would not listen, they did not know how. Perhaps they'll listen now, for they could not love you, but still your love was true. And when no hope was left inside on that starry, starry night, you took your life as lovers often do. But I could have told you, Vincent, this world was never meant for one as beautiful as you.
When a group of people representing the National Alliance for the Mentally Ill who have really experienced the sorrows of mental illness see this, there's often not a dry eye in the room. Well, let's go on to the main presentation, which is about the nature of creativity. And we'll touch toward the end on the subject of creativity and mental illness. Here's my slide advancer. So when you think about creativity, the very first thing you have to ask yourself is, what in the world do we mean by this word, creativity? And there are a variety of ways that it can be defined, and we'll talk about a couple of those in a second, but I'd like to begin with this, which is a poetic definition of creativity. Creativity is the ability to see a world in a grain of sand, and a heaven in a wild flower, hold infinity in the palm of your hand and eternity in an hour. Beautiful lines. Well, as people have thought about this important topic down through the centuries, they've asked, how does creativity relate to intelligence? Are people that we call geniuses, are these people that have a high IQ, or is it something different? And how do we relate having a particular talent or skill to being creative? These are both fundamental questions, and I'll touch a bit on the first one in particular. A very mundane verbal definition, non-poetic, is that probably the best way to define this is to say that it's the ability to perceive and produce novel ideas and products that are useful to mankind. And of course, by useful, I don't mean just practically useful as in inventing the assembly line, although that was a creative contribution, but of course, useful in the way that the art you were just looking at is useful. It expands the imagination and elevates the human spirit. One of the landmark studies early in the study of genius was done by a man named Lewis Terman. And there's some confusion when you hear people talk about creativity because it's sometimes used as synonymous with genius, and genius is sometimes used as synonymous with having a high IQ. And in fact, if you read 19th century literature, you don't hear the word creativity at all. Everybody's called a genius. And in the 20th century, we do speak more about creativity, but we still use the words sometimes interchangeably. Well, Lewis Terman was a Midwesterner, like me. I think of myself as an Iowan rather than a Nebraskan, but anyway, a Midwesterner. And it's actually a big difference. Iowa looks east and is quite liberal, and Nebraska looks west and is quite conservative. Anyway, Terman was a Midwesterner. He was actually from Indiana, even further east. And he was a very bright little kid. He was precocious, he skipped grades, and he was subjected to a stereotype that prevailed at the time that it wasn't good to be a bright little kid. That if you were too bright as a youngster, you would flame out when you became an adult. The early ripe, early rotten hypothesis. And I suppose he instinctively didn't want that to happen to him, and perhaps he instinctively knew it didn't apply to him. So he began to do a study, at the time he did his PhD dissertation, of gifted kids to see what happened to them as they matured. He had to leave the Midwest to go out to Stanford, poor guy, ultimately become the chair of this psychology department out there. And when he got out there, he adapted the IQ testing that had been developed in France by Binet to an American version. And I'd like to point out in the era of greed that Terman was such a nice man, such an idealist, that when he invented this test, he didn't name it after himself, as so many people do. He called it the Stanford-Binet test. And when he started earning a lot of money, all the money was donated back to his university and his psychology department to further research. So he was a kind of role model for the rest of us. When he got out there, he started a very, very famous study that was ultimately published in 6 volumes, a genetic study of genius. And what he did was identify kids in the California school system who had IQs measured using his type of tests that were in the 135 or over range. And he did a very imaginative thing for the time. He made this a prospective longitudinal study. These kids were assessed when they were kids. They were assessed every decade thereafter, on up into their 70s. So we have this very interesting description of what happens to high IQ kids born in California in the 1930s or so. And what came to be, and my English doctoral dissertation supervisors wife was a psychologist who worked with Terman. So I got to know this study really early, and I read it all when I was still in English. What came to be discovered was that these kids who had high IQs, as they grew up, in some ways were much better. They were less neurotic, better adjusted, even taller, overall healthier, better mental health. They actually entered puberty earlier. He had a control group. And so the stereotype of the highly intelligent little kid didn't pan out. These were not, you know, wimpy little kids who were all nearsighted and geeky. They were reasonably cool kids, or reasonably cool adults. But the surprising thing was that as these people hit their 30s and 40s, when as geniuses they should have been producing great creative contributions, they didn't really do very much of anything. They were economically successful, the majority, although not all. They were upper middle class, or middle to upper middle class successful people, but almost none of them was a recognized creative genius of that era, our era. In fact, he missed 2 Nobel Prize winners who didn't make the IQ cut to get into his study. And the people who did get in, not a single Nobel Prize winner, not even an Academy Award winner out in California. So, bottom line, having a high IQ does not guarantee that you're going to be creative. And being creative and high intelligence are just not the same thing. They may be co-occurring in some people, but one does not produce the other going in either direction. So that's the issue of intelligence and creativity. Let's move on to thinking about the brain itself and think a bit about how the brain thinks. And to think about that, we have to think about the brain. How many of you have some interest or training in neuroscience? So a modest number. It is often said that the human brain is the last frontier in science, and I really think it is true. And that New York Times article that was alluded to at the beginning definitely makes that point. In general, I think we can say that the 20th century was the age of physics, and the 21st century is going to be the age of biology, and the jewel of the crown of biology is the human brain. Well, the human brain is extraordinarily complex, which is one reason we in neuroscience stand in awe that it contains 100 billion neurons, or nerve cells, just in the cerebral cortex, our big brain that sits up here. And if you want to think about that metaphorically or poetically, it's the same as the number of stars in the Milky Way. And then, in addition, the cerebellum, our little brain that sits down here, has even more neurons than the cerebrum. And then so that's a quadrillion neurons. Quadrillion is really more precise than gazillion. I had fun thinking about this because I was trying to figure out how many exponents one would add on to get to really big numbers. And at one point I thought I was going to have something very poetic, but it didn't pan out. So I just settled for quadrillion. But anyway, when we think about nerve cells, as you just heard, you've got this neuronal cell body, but that neuronal cell body has coming out of it axons, and then it also has dendrites. And out of those come spines. So let's say we have a dendrite, then we've have the spines sitting on the dendrite, and multiple ones. And then on those spines you have synapses. So a single nerve cell has this enormously multiplied capacity to talk to another nerve cell. And think about quadrillion nerve cells in the brain, and all the synapses and spines, 1,000 to 10,000 per nerve cell. And it becomes evident that the complexity of the brain is enormous, and the ability of pieces of the brain to communicate with one another is enormous, which is why we stand in awe of it, and why our human brains have such extraordinary creative capacity. I mean, if you think about what we have done from the time we emerged from caves to where we are now, we have, you know, obviously art and poetry and theater and politics and all those things. We have roads, we have buildings, we have airplanes, we have spaceships. I mean, we are unbelievably creative creatures. And we are unbelievably also creative in figuring out how to harm one another, which is our evil side. So you've seen pictures just about like this one here, except these are the textbook versions. I guess I don't have a pointer, but there in the middle, that little skinny thing is a dendrite with spines on it, and then on those spines you can't actually see the synapses, but they're there. That beautiful cell on your right is a Purkinje cell, which is enormously branched. And in general, you can see in the central nervous system these nerve cells that have so much capacity to communicate. The other thing about it is that they don't just go neuron to neuron, they have feedback loops so that they can create reverberating circuits that keep on talking back and forth to one another. Well, all human beings have the capacity to be creative. And in fact, in doing research on people who are creative and finding a control group, we have come to say we're studying super creative people and just regular creative people. One very simple example of how we're all creative comes from language. Our ability to talk to one another is something we take for granted all the time. I come here today, I meet people that I haven't met before, we discuss things that I've not discussed with other people before, and all the time this intercourse, this discussion occurs, somebody makes a statement, I listen to it, hear what he or she says, am formulating a response in my mind, and then speaking it. And I do that, you do that, we all do that all the time on the fly. That's a creative process. Because what we're saying when we have a conversation with a new person is new material, it's something we've never said before, and we are amazingly able to do that very complex act of listening, comprehending, formulating a response, and replying, and we do that back and forth, and that's what a conversation is all about. A conversation is a creative process. And we, as human beings, really are the only creatures that have a highly developed language so that we can interact with one another so creatively. Well, the question is, how do we do that? I mean, where do we get this amazing capacity to do something novel, spontaneously? And to understand this, I'll have to go into an idea that's quite popular in modern physics, the idea of self-organizing systems. How many of you are familiar with that concept? How many of you know what a self-organizing system is? It's interesting to me how this isn't in general knowledge. And I would really recommend that, you know, if you're curious about the stuff I'm talking about, that you go get a book written by a fellow named James Gleick. It's an old book now, written about 10 years ago, and it's called Chaos. And the idea of self-organizing systems is popularly linked to a term called chaos theory. So you'll learn a lot about it, and once you learn about it, you'll, I think, have your minds expanded, because it really does explain a lot of what goes on around us in the world. So a self-organizing system is one that behaves in a way that's nonlinear. And obviously, you know what linear is. If you hit a tennis ball with 2 pounds of force, it'll go at a certain velocity. If you hit it with 4 pounds of force, it'll go twice as fast, and so on out in a linear function. The notion about self-organization is that it is not linear. It's nonlinear, and not only is it nonlinear, but it is dynamic, or it's stable. It's subject to frequent changes. So it's a different animal from what we see in, say, simple Newtonian mechanics. And what that means is that within these unstable, spontaneously self-organizing systems, prediction is more difficult. And as the saying goes, a small cause can have a large effect, or a large cause can have a small effect. The common example is a butterfly flapping its wings in Beijing, literally affecting weather systems in Florida. And this is actually a potentially real example. Things like that do happen in weather prediction. If I'd been thinking about it well enough, I would have come up with a little tiny example from contemporary economics, where we could also see that a small cause is having large effects in our current economic situation. So that's one aspect of self-organizing systems. Another aspect is that, as the first sentence runs here, the whole is greater than its parts. So in a self-organizing system, you have a very complex array of components. And within that complex array, there is no central executive making the decisions. This is an especially hard concept for neuroscientists to embrace, because they're accustomed to thinking of the brain as subspecialized and having within it the frontal lobes, which are the executive system. But in real life, in truth, the human brain doesn't have an executive system. There is no little ghost sitting inside my head telling me what to do. There's no little ghost organizing anything. That are my thoughts and prioritizing them and so on. When I'm thinking, or when you're thinking, when any of us are thinking, we are continually, spontaneously reorganizing without a single dictator, executive saying what to do. It's a very interesting but absolutely true model of how the brain works. So the control isn't centralized, it's distributed throughout the system. Just to give you a simple little example, if people have gone to a concert and heard, beautiful music performed, say Mozart or whatever, and after the performance is over, they have enjoyed it so much that they start applauding, as we do. But this was especially good, and so instead of all applauding at random, they eventually start the entire audience applauding in unison. When that happens, it's not that one person said, let's applaud in unison to show how much we appreciated it. It's control distributed throughout the audience, and all those people together spontaneously agreeing to express their appreciation by that applause. So that's perhaps a small but also useful way to think about a self-organizing system. So, in the world around us, once you have this concept, you'll see it all the time. It occurs in the flocking of birds, and the schooling of fish, swarming of bees. Things that we're especially worried about now, changes in our ecosystem due to climate changes, changes in predators, all the things that are occurring as, China builds more buildings and Brazil cuts down more trees and so on. And then the thing that is, this is a pre-recession slide, but the last point on here is particularly telling. Changes in the economy due to changes in geopolitics and natural resources. It's become really clear, there is no central executive controlling world economics, just as there is no central executive controlling our ecosystems. It is genuinely in a state of chaos and continually self-organizing. A little bit terrifying, that fact, but it is the way it is. So that's how the brain thinks. The brain is a self-organizing system. How does the brain think creatively? And to talk about this, I'm going to have to give you some examples of introspective accounts by a variety of creative people. One of them comes from Samuel Taylor Coleridge, a 19th century poet. And you'll all know a little bit about Coleridge because you've heard of Xanadu. Xanadu comes from a poem, the term Xanadu, the pleasure dome that was being built here in New Jersey. The name was chosen from this poem by Coleridge called The Road to Xanadu. How did Coleridge come to write that poem? Well, he was quite a young man at the time. He was in poor health. He went out in the country to relax. He took some opium, as was not uncommon then among people. It was used as a therapeutic medical agent. And he was reading a travelogue. And while he was reading that travelogue, he fell asleep. And this is his own personal account of what then happened. He was about 3 hours in a profound sleep, at least of the external senses, during which time he has the most vivid confidence that he could not have composed less than 200 to 300 lines. If that indeed can be called composition, when the ideas rose up before him as images, as things, with a parallel production of the corresponding expressions. So he was seeing visual images, hearing the words while he was in this semi-sleepy state, and had no sensation of consciousness of effort. So this all just happened spontaneously. Then what happened was that he woke up, and he had this great poem. He started writing it down. There was a knock on the door. He got up and answered it. He had to go run an errand. Came back. It was all lost. All we have left of that poem is about 40, 50 lines, which became a fragment, as he called it, Kubla Khan, or a vision in a dream. Another person talking about how he creates, Neil Simon. Actually a cute story too, because I happened to be on a plane going to the Clinton inauguration, and seated next to me was a fellow, fairly unassuming looking fellow reading a novel, Tender is the Night. And, back then you had flight attendants who came by and asked you what you wanted for lunch and things like that. So the flight attendant came by and said, "Mr. Simon, what would you like to have for lunch?" And he told her, and "Dr. Andreasen, what would you like to have?" And I looked over at him. I said, "Are you by any chance Neil?" And he said, "Yeah, I'm Neil." I said, "Gosh, I'm one of your big fans. I've seen every play you've ever written." And we went into this huge, long discussion of the nature of the creative process and how he worked. And it was classic, just as all of these are. He described how when he writes a play, he goes into an altered state. He slips away from reality and is just lost. He described how he never writes consciously. In fact, it just comes. It's as if the muse sits on his shoulder. In fact, some people plot out their plays or their novels. He never plots out anything. And he doesn't even know how a play is going to end until he comes to the end. He never lets himself figure that out. He said, if I did, it might spoil it for the audience. They might figure out what was going to happen. This is a nice one from Mozart. When I am, as it were, completely in myself, entirely alone and of good cheer, say, traveling in a carriage or walking after a good meal, or during the night when I cannot sleep, it is on such occasions that my ideas flow best and most abundantly. Whence and how they come, I know not, nor can I force them. My subject enlarges itself, becomes methodized and defined, and in the whole, though it be long, stands almost complete and finished in my mind so that I can survey it, like a fine picture or a beautiful statue at a glance. And this is the part I love. Nor do I hear it in my imagination, nor do I hear in my imagination the parts successively. It's nonlinear. but I hear them, as it were, all at once, like, oh, it's too solemn. What a delight this is, I cannot tell. All this inventing, this producing, takes place in a pleasing, lively dream. Wouldn't be complete without an example from math or science. So this is Poincaré. One evening, contrary to my custom, I drank black coffee and could not sleep. Ideas rose in crowds. I felt them collide until pairs interlocked, so to speak, making a stable combination. By the next morning, I had established the existence of a class of Fuchsian functions, those which come out of the hypergeometric series. I had only to write out the results, which took but a few hours. So there's a theme here. Original ideas come when you're in a special state of mind, a relaxed state, a dreamy state. You can't force them. They have to occur spontaneously. It's, you know, what we tend to call inspiration. I put up as the first slide the cover of a book I wrote about this. I wrote it for the Dana Press. Dana specializes in brain books, and they wanted me to write a brain book about creativity. I thought, well, this is all very nice. The problem is that there is almost no research on the brain and creativity. And you know, I knew of a few little pieces that I was able to bring in, but I said, how am I going to figure out a way to say anything really solid about the brain? And then it occurred to me that I'd written this book that Julian Keenan, or this article that Julian Keenan referred to, Remembering the Past, Two Facets of Episodic Memory Explored with Positron Emission Tomography. What this article is really about is the nature of the unconscious and the nature of the creative process. And what I realized and argued in that article is that when we let our brains wander freely, just think about whatever comes into our mind, we approach something like the unconscious state. And we were using rest, random episodic silent thought, as a control condition in our PET studies for some experimental condition like remembering a word list. But I kept saying, you know, this is not rest. The brain doesn't rest. So let's look at this other state of the mind wandering freely and see what characterizes it. And this will be interesting because, after all, this is what Freud was trying to get at when he tried to study free association. Free association is really nothing more than letting your mind wander freely, saying whatever comes into your mind. And it had been a very powerful way to think about the mind and the unconscious, exploited by people like Joyce in Portrait of the Artist as a Young Man, or Faulkner in The Sound of the Fury. And what we're doing when we free associate is classically primary process thinking. It's free and uncensored thought. It's just what spontaneously occurs. And this free and uncensored thought is the resource for creativity as well as dreams, religious experiences. So, what part of the brain is most active during rest? Now, this is a PET image, and the experimental task you're looking at in red, and that's this verbal task, semantic memory in this case. And the areas you see in blue are the areas that are active during rest. And so those blue areas, I bet this is a pointer, yeah. So these blue areas are prefrontal association cortex, parietal association cortex, we've got temporal, I can't see these very well, but there's temporal association cortex, occipital association cortex. All the association cortices in the brain are the ones that are active during rest. Now, for those of you who aren't in neuroscience, as we talk about the brain, we talk about areas that are specialized and dedicated, like we have a motor strip that is letting me move my hand right now. We have a sensory strip that's right next to it so that we feel sensations. We have primary auditory cortex that permits us to hear, visual cortex that permits us to see, but particularly for those auditory and visual things, they intrinsically have no meaning. If you are, say, reading a book, what comes into your brain is the black and white letters on the page. That's what registers in your primary visual cortex. To actually be able to read and understand what you're reading, that black and white image has to get forwarded on to visual association cortex, where those letters are attached to meanings, and then your brain spontaneously says, I am reading a book, or the book says this, or whatever. So association cortex, its job is to connect things to one another in order to extract meaning. So it's not a very far leap from that to realizing, gosh, what must be especially prominent in the creative process is activity in the association regions of the brain. And potentially people who are highly creative are people who are going to have especially good association cortex. Somebody like Shakespeare, who had a larger vocabulary than anybody else before or since, probably part of that creativity was just his huge reservoir of verbal capacity to make verbal connections. This is just an image that shows you these association regions in the brain colored in yellow. And the interesting thing about these ontogenetically is that they're the last parts of the brain to mature. A 15-year-old is still growing association cortex. A 25-year-old has a mature brain. So how does the brain create? Well, the thought that goes into creativity is not just dynamic and nonlinear. The unconscious has to play a role. And I think, and hopefully eventually we'll demonstrate that empirically, scientifically, that during a creative process, what's happening is that the association cortices are just bouncing things back and forth in a, sometimes highly random or very chaotic way. Occasionally, as these creative people have described, things interlock. They come together and make sense. Wow, we have a novel idea. And so out of that meaninglessness comes a novel thing. The brain has to, in a sense, just disorganize in order to reorganize and produce a new idea. Well, that's a lot of background. Now let's look at some practical data. First, I'm going to talk a little bit about a study I'm doing right now, which is hugely great fun. It's a study of highly creative people. I'd probably make a good person from New Jersey because I have Iowa pride. You should have New Jersey pride. So I call this the Iowa Study of Creative Genius to make a little bit of publicity for Iowa. What I'm doing is bringing in 30 highly creative artists, 30 highly creative scientists, and then matching them with 30 normal individuals. The working hypothesis is that creative people will have more active association cortex than the controls. And I'm using 3 tests in fMR, a way of imaging brain activity, a word association, a picture association task, and a pattern detection task. To get into this study, you have to become notable for doing something, whether it's Academy Awards or Nobel Prizes or Lasker Awards or whatever. So this is one of my highly creative subjects. This gentleman looks so much like my husband Terry that when I first started showing slides, people didn't recognize him. So I had to put in the clues of the lightsabers and so on. What they do is come to Iowa City for a couple of days They get interviewed about how they work, how they think. They get an anatomic and a functional MR, cognitive testing, and then they get debriefed. They get to see their own brain, both structurally and functionally. We give them a little book. We're very proud of the fact that we could process the data so fast that every subject the next day in this book has not only pictures of his brain or her brain, but was told, well, you've got 1,251 cc's of brain tissue, and so many cc's are gray matter, and so many are white matter, and so many are left hemisphere, right hemisphere. And I think every single subject finds this extremely fascinating. And ultimately, they get a little model of their brain that we reconstruct from their MR scan. So what have we learned so far? Well, the 3 tasks do strongly activate association cortex. There are task-related differences. The verbal is, obviously uses more verbal association cortex than the visual one. The creative people do seem to be having more prominent activations. And interestingly, the patterns across the artists and scientists are essentially identical, which is what I had hypothesized. This thing doesn't seem to work very well. Okay, so here's an example of a creative subject with his activations in association regions as compared to a control subject. And another for picture association. I suppose I find this topic especially intriguing because I've lived in both the world of the arts and the sciences. But why would artists and scientists have similar brain activations? Usually we think of these people as being very different from one another. I think it's really cool that you just heard tonight that a visual artist could be inspired by science. And believe me, do I ever see those trees waving like dendritic arbors? I talk about it probably every day. I think the creative process is very similar in art and science. Both require flashes of intuition and insight. And also, when you start looking, it's surprising how many creative people have interests in both fields. As it says here, Einstein played the violin, Jim Watson writes books, and there are many other examples. And potentially being a polymath, which literally means knowing many things, mathe, to know, poly, many, probably enhances creativity because people can see a big picture. This has interesting implications for education, I think, because there's a tendency to encourage people to specialize early. It's much greater in Europe than it is in America, and I think one reason that we in America are ahead technologically is that we don't require somebody to get on a track when they're 18 years old and stay on that track the rest of their lives. That is what pretty much happens to people in France or Germany or England. And here we have the opportunity to do multiple different things if we want. Anyway, think about George Lucas. If you ask him what he does, he thinks he's a writer. And actually, he is a writer. He's very proud of the fact that he wrote all the scripts for not only Star Wars, but all the Indiana Jones. And in fact, I thought I was going to get him to help me recruit Steven Spielberg because he had such a good time. I said, so who else is highly creative, do you think, that we might recruit? Well, he didn't know. This is also pretty typical of these people. They're a little egocentric. Nobody else is quite as creative as they are. And so I said, well, what about Spielberg? Oh, Steven. Well, Steven, I don't know. Steven doesn't write any of his material. He borrows it from somebody else. I said, but wouldn't you think he's pretty creative? Well, he's a genius as a director. He can really direct. So it's just interesting. This is a fun study. But Lucas, writer, film director, National Medal of Technology for digital imaging and computer graphics, and a very successful businessman. He covers all the bases. And he's also just an incredibly nice man. Well, let's turn to this final theme, creativity and mental illness, and talk about whether there's a relationship here, and if so, to what kind of illness and to what kind of creativity. This is an idea that's been around for centuries. We have here a quote from Aristotle, those who have been eminent in philosophy, politics, poetry, and the arts have all had tendencies toward melancholia. You've got Dryden, great wits are sure to madness near allied, and thin partitions do their bounds divide. Fine line between genius and insanity. And there are many examples in real life. This is in the Starry, Starry Night thing. Miro had severe mood disorders. And that is one of the saddest paintings you could possibly look at. Self-portrait. Somebody asked me today if doing a portrait is creative. And I think anybody who can express an emotion in a face like that has to be said to be creative. Faraday had really severe bipolar disorder. And there are numerous examples. Julian mentioned some of my firsts. One he actually didn't mention was that I did the first empirical study of creativity and mental illness long ago, and I was able to do that when I was transitioning from literature to medicine. The University of Iowa has the Writers' Workshop, which is the oldest, most famous creative writing program in the world, and I knew many of its people over the years because I lived next door to them. Kurt Vonnegut, John Irving, Robert Lowell, Jory Graham, Gail Godwin, Philip Roth, John Cheever. It's basically a who's who of contemporary American lit. So in that study, I interviewed my subjects about their creative history, social, psychiatric, family history. This was in the pre-diagnostic criteria era, but I created a set of criteria so it would be objective, and basically tested them a variety of ways and had a control group of, quote, non-creative people. Sometimes, when I'm talking about this topic in a medical center setting, sometimes people say, well, where do you get the non-creative people? Long pause, and then I say, well, what about hospital administrators? And that is where I got some of my controls. This study is an old study now. It started in the 70s, and it took me 10 to 15 years to finish it. It would probably take me 10 to 15 years to finish the one I'm currently doing as well. It's slow, but it's fun. The hypotheses were very much shaped by my previous interest in English. I've been fascinated with James Joyce, who had a daughter with schizophrenia. And so I thought I was going to find schizophrenia in the first-degree relatives or parents, siblings, offspring of my writers. Somehow I thought I had Bertrand Russell in here too. Anyway, Bertrand Russell was another person who informed my ideas because he had a family that was loaded with schizophrenia. I expected the writers to be normal, and I thought that they would have some differences in cognitive style from the non-creative people. When I started interviewing these people, I was absolutely astounded because one after another they came into my office. First of all, I was a young psychiatrist and I didn't think anybody in the world would want to talk to me. They came into my office and they just bared their souls for 3, 4, 5 hours. And what came spinning out was that many, many, many of them had experiences with severe depression. And that's basically what's summarized here. My writers had no history of schizophrenia whatsoever, either in themselves or in their family members, which is on the next slide, but they had a huge rate of mood disorder. I guess our columns got out of order there, and likewise here. Anyway, this is scrambled also, but bottom line in terms of their family members is that the family members had an increased rate of mood disorder, and the families had an increased rate of creativity. Come on, here we go. So when I got all done with the study, what I realized was that, contrary to what I hypothesized, the writers had mood disorder, not schizophrenia. Their family members had mood disorder, not schizophrenia, and they were more creative. And so there must be some kind of diathesis that runs in families. It could be genetic, it could be environmental, it could be both, that predisposes to both mood disorder and creativity. Well, what about the other relationship with schizophrenia? When I finished that workshop study, I said, I wonder what I would learn if I studied a different kind of creativity. What if I looked at physicists? Or what if I looked at composers? Or what if I looked at visual artists? So I always wanted to do another study, which is what I am doing now. So, to return to that question I started with, is there a relationship with schizophrenia? And it's still worth thinking about. We have the example of John Nash. Well, is there any empirical evidence for a relationship between schizophrenia and creativity? This little piece of the talk got put together 3 years or so ago when I had to do a Nobel symposium with the title Schizophrenia and Creativity. And much as I worried that there wasn't enough evidence about the brain and creativity, there was really no evidence about schizophrenia and creativity. So I had to get creative. And so I filled up the talk with some workshop stuff and some anecdotes, and then I used this. If you think about it, what have been the most important discoveries since the dawn of modern science? Probably, you might say, kind of Galileo Copernicus. You would probably say Newton. You would probably say, could say theory of evolution, Darwin. You could say theory of relativity, Einstein. Those would, and you could say the discovery of DNA, molecular biology. Those would probably be the biggies. So let's just focus down on a few of them. This actually is a slide that was meant to pad the talk a little further, to talk about when science began, and it is worth thinking about how young science is. It's only been around since the Renaissance, when people began to want to observe and to know through direct observation, as opposed to received knowledge handed down by the church. And this is the motto for modern science from the Novum Organum of Francis Bacon, which was the first manifesto on the nature of science. Man can act and understand no further than he has observed, either in operation or in contemplation of the method and order of nature. And there's really so much to be gained, both in terms of creative resources and just general knowledge, by looking at the world around us, nature around us, and thinking about it. So I mentioned the possibilities. Let's just look at these three. First, Newtonian mechanics. Another little couplet from Pope. nature and nature's laws lay hid in night. God said, "Let Newton be," and all was light. Well, probably very few of you knew that Newton was born prematurely. He was an odd kid. He was an odd adult. He was chronically suspicious. He never married. He lived alone. He had a psychotic break at age 40, which is well documented. And throughout his life, he had unusual interests and beliefs. Surprising for somebody who did what he did in physics. Theory of relativity. Again, Einstein was a very strange man. This recent biography that Walter Isaacson wrote makes it very clear. He was, on the one hand, he was totally sweet to the world in general, but completely obtuse to the people closest to him. Just seemed to lack, sensitivity and tenderness. Was, slovenly, what we would call schizotypal, and he had a son with schizophrenia. And then there's the structure of DNA, and Jim Watson, who also has a son with schizophrenia. So, the three of the most important discoveries of modern science were all done by men who had an association with schizophrenia. What are the odds of that occurring by chance? And I think there must be something there, because I also, in addition to these people, know a bunch of other prominent scientists who have kids with schizophrenia. Almost always males who have sons. Schizophrenia is a heavily male disease. So the question is, does carrying that diathesis confer an ability to perceive in a very original way and to see new and different relationships? And is that ability related to the cognitive traits that we see in people with schizophrenia? These are often referred to as loosening of associations, so that if your capacity to make links is just a little bit mixed up, you may end up perceiving things peculiarly and having a schizophrenia-like picture. And yet, if you just see things a little less peculiarly, you might be original and creative. Or, as I like to say, there are some people who see things that nobody else can, and they're right, and they're creative. And some people who see things that nobody else can, and they're wrong, they're psychotic. And then there's some people who do both, like John Nash, and they're both. When John Nash was hospitalized at McLean, at age 30, a friend came by and said, "How can you believe that you're being recruited by aliens from outer space to save the world?" And he answered, "Well, because my ideas about mathematics came to me the same way my ideas about supernatural beings came to me the same way that my mathematical ideas did, so I had to take them seriously." I mean, that really just about says it all. So, creativity is a mental gift that permits people to perceive things in novel ways and to see things that other people can't. And it's shared across disciplines, I think, including math on the one hand and literature on the other. And, if you do see things in a novel way, you are going to be a little bit different. And you may be, therefore, more vulnerable to mental illnesses such as schizophrenia or mood disorder. This is not to say that creative people are inevitably mentally ill at all, but rather that there is a relationship in some people. And we should understand that and appreciate it, and I think embrace the fact that these people are different, understand it. So I'm going to end with poetry and then music. These are the last lines from The Road to Xanadu. song, Vision in a Dream. And I think it describes a little bit about the nature of the creative process. Beware, beware, his flashing eyes, his floating hair. Weave a circle round him thrice, and close your eyes in holy dread, for he on honeydew hath fed, and drunk the milk of paradise. Or, to have a slightly brighter note that I started with, think about achieving the ability to see a world in a grain of sand, and a heaven in a wild flower, to hold infinity in the palm of your hand and eternity in an hour. So I would like then to end with the music that I started with and have you think again about the motto of the National Alliance for the Mentally Ill: people with mental illness enrich our lives.
Starry, starry night, flaming flowers that brightly blaze, swirling clouds in violet haze, reflecting Vincent sides of China, colors changing, morning fields of amber grain, weathered faces lined are soon beneath the artist's loving hand. Now I understand what you tried to say to me, and how you suffered for your sanity, and how you tried to set them free. They would not listen, they did not know how. Perhaps they'll listen, for they could not love you, but still your love is true. And when no hope was left inside on that starry, starry night, you took your life as lovers often do. But I could have told you this world was never meant for one as beautiful.
Some questions and answers? Questions? Richard here?
Seems like schizophrenia is a balancing point. Would you say that even it's schizophrenia, or is it vice versa? So he start off with schizophrenia
I don't think one causes the other in either direction. I think that, we are really complex creatures, human beings, and so we start out with, mental traits that some of which we're born with. A lot of us is shaped by environment, and so, if a person has a parent with schizophrenia, say, their chances of developing it are increased by 10% or so. But, so that's a genetic diathesis, but it may take quite a bit more on top of that to push a given person over the edge into having schizophrenia. Then I think in parallel with that is the diathesis to perceive in an original way, which is what we think of creativity as being. And I do think that when somebody has the tendency to perceive differently, they are going to be perceived differently by others, and that may make them more vulnerable. But seeing things differently doesn't lead to schizophrenia, it doesn't lead to mood disorder, and having mood disorder or schizophrenia sure doesn't lead to creativity either. So they move along with a common pathway. It may end up as both. It may just end up going one way or the other. But it's not this causes that or this causes that. It's, I hope I made it clear. It's a pretty complicated topic. Yeah?
Earlier in the question, you talked about the idea of how it seems like a lot of people come up with their grand ideas when they're like out wandering or like at nighttime or some of that. What do you think is the nature of that environment that allows the creative process? Or is like just there's something about that environment that doesn't allow thought or
I don't know if he asked why people would have more ideas when they're out wandering or, it was sort of a state of sensory deprivation, really. And, I mean, I'll tell you, I've talked by now to so many creative people, they all say the same thing. I get my ideas in the shower, I get my ideas when I'm running, I get my ideas when I'm swimming, I get my ideas when I'm about to fall asleep or whatever. So it's a really common theme. And I think that what happens is that people they're just going into another mode. They're not doing what's on my grocery list, and they're not doing what are we going to have for dinner, or what movie do I want to watch, or whatever. What's my assignment in such and such class. Their minds are just free to think of whatever they. So that state of kind of mental wandering, mind wandering, lets things percolate, and it's this bouncing back and forth, and then sometimes, the idea hits, and the person says, aha, and it's just so true. And there's a message there, which is that there's another poem by Wordsworth, the world is too much with us, getting and spending, we've lost our powers. I can't quote it from memory, but we probably shouldn't all be as busy as we are. We ought to really make more free time for thinking. If we're raising little kids, they shouldn't really be going to soccer on Monday and ballet on Tuesday and, tap dancing on Wednesday and so on. People need some freedom. We'll get to you too. She's just waving her hand so strenuously.
Just wanted to get your attention. So many famous musicians and artists, they use chemical substances to achieve this dreamlike state that you talk of. So I was thinking, would these people still be considered creative? And would their brains be linked like the people you have in your studies? Would their brains be the same?
The very first part you said, would these people be considered creative?
Well, yeah, would they still be creative? Or
no, what you said just before that, I didn't quite get it.
Oh, they use chemical substances like drugs, alcohol to enhance their creativity.
For better or worse, a number of people do that. I don't think it's the royal road to creativity, and I think it's much better to get there without it. But, again, my writers, something like, I forgot, like 30% had significant alcohol problems. From my point of view, it's almost self-medication for a finely tuned nervous system. I think taking the hallucinogens and so on is a much less promising way to induce creativity, and very dangerous, actually. So I guess part of the question is, are the things that are created through artificial stimulation, can they be considered creative? I guess I'd say if they really are creative, yes. But a lot of it is just kind of delusional belief, when you're in that particular state of mind. Familiar first cousin of it is the manic phase of manic depressive illness, where when people are manic, they think that they're very grandiose and they think that they're discovering great things, and then when they come down to reality, stuff is no longer so great. So the question over here, somewhere.
If you think about Michelangelo and Da Vinci, do you see any relationship between homosexuality and creativity?
Only heard part of the question. You're asking, is there a relationship between homosexuality and creativity?
Because of Michelangelo and Da Vinci were gay and not.
Because of what?
Michelangelo and Da Vinci were both gay.
Oh, okay. We don't know that, we don't know for sure about either one of them, but I think it's probably at least plausible for Leonardo. Michelangelo, I don't know of any real solid evidence for him. I think I guess if you look at it statistically, there are a number of people who are homosexual who have been highly creative. The thing about homosexuality is that it is so, whether it's known to be occurring or not, is so socially dependent. And there are even times when it's considered to be a very good thing, as in, say, Sparta in Greece, 5th century Greece. There are times when it's considered anathema, as during the Middle Ages. There are times when it's considered kind of cool, as in Victorian England. You know, the intellectuals like Oscar Wilde. So we really don't know. We really don't know how many people have been homosexual and creative, or could have been homosexual, but were not even allowed to express it. In other words, it's one of these things that is much more socially determined. Well, okay.
Dr. Anderson, I think Van Gogh would probably be one of the first to tell you he could not write a symphony. James Joyce would probably agree that he couldn't paint, or he couldn't paint in any genuinely original way.
He sure thought he could sing.
He thought he could sing, and he thought he could write poems. The creative genius, the creative thought, is nothing more than thought unless it finds expression. And all of these geniuses that he described have been geniuses of expression. Coleridge was, a well-advanced poet and writer by the time he had that dream. Poincare was obviously a mathematician by the time he had that fantasy. I can't remember where or what the study was, but I recall a study of writers which purported to demonstrate that no serious writer could produce any work of genuine, original quality without at least 10 years of practice at the craft. And the recent exhibit of On the Road, Kerouac, which we had here at the Public Library in New York, demonstrated that while his aesthetic was, first thought, best thought, meaning write at top speed, don't stop, don't rewrite, just do it. He didn't come to that until he had been monkeying around and writing and practicing and playing for well beyond 10 years before he wrote On the Road. Could you comment on the need for the artist to have developed the craft and the practice which is necessary for genius to actually express itself?
Well, that's a really good question, because the answer is both sides are true. Being in Renaissance lit, I often think about comparing how difficult it is to write a sonnet as compared to, say, free verse. And gosh, the craft that goes into writing sonnets is so great, and people who do it well are so admirable. So, yeah, there's definitely a craft side to all kinds of things, whether it's art, whether it's writing poetry, whether it's doing music, or whatever. But I guess it goes again to this issue of talent versus genius or creativity. The thing that produces something truly original has to go beyond craft. So we don't minimize getting the fundamentals. If you don't have those, you may not be able to do anything. But you shouldn't minimize the spontaneity and the intuitiveness of it either, I think.
Yes, but you did say that Shakespeare had a very, very rich vocabulary, and that would give him more opportunity to express himself creatively. So if you don't make a commitment to developing a basis, wouldn't it somewhat inhibit your ability to express yourself creatively? Because you did cite Shakespeare.
Yeah,
As a person
you
who
make
had-
a point similar to his, that
Yes.
you can't be a genius out of nothing, which I think is a very good message to give. I would quite agree, especially in a college environment where we're supposed to be learning something. Somebody with a deep voice is saying question, but I can't see where. Up there. The brain what? Is the brain infinite? Maybe? Yeah. Maybe. I don't know how to quantify, prove that the brain is infinite, but it seems to have that quality up there in the balcony over red. Could you talk just a little louder? I wish we knew the answer to that. This is a little bit like Is the Brain Infinite? I don't think we can say you have to go through a certain number in order to get there, but you certainly have to go through some. I suppose occasionally somebody does a hole-in-one or a home run on the first effort. Not that commonly. Recessive in a population? You said creativity is recessive in a population? Stifled. I'm actually reasonably traditional, so I'm puzzled to find myself sounding so untraditional. However, I will say that, society is structured not to favor the original. The original is annoying, and it's much easier, to have everybody be the same. I use a couple examples of, I used to teach literature. I used to even have to teach writing, which I didn't like to teach. And I did realize it's really tough to teach people to write, but you can give them a few basic skills. And one of them is to teach them about different kinds of structures that they can use. And one of them is, in general, telling people to do an outline is helpful. The other side of that is that there will be people, I happen to be one of them, who could never make an outline. And it was literally painful for me as a little kid in school to have an English teacher say, okay, Nancy, outline your paper and then write it. And I kept trying to explain I couldn't outline it because I didn't know what I was going to say, because I never knew what I was going to say until I started saying it. And that's the more creative approach to writing. And I think if a teacher hears a kid say that, then a bell should go off that this kid shouldn't have to make an outline. Same way with the kids who can solve math problems just with a leap. And then just some of them drop out of math when they're told over and over, show your work, because that's just annoying. So, you know, it's a tough balance to recognize and reward the, you know, the original, the unusual, the person who's a little difficult, and at the same time provide the structure for the people who need it. Which, I mean, I would totally agree. There's a craft, there's a structure people have to learn.
I have a question. If there have ever been any studies done, or if in your studies you look at the childhood of the creative people, I'm just wondering if they were exposed to greater stimulation in their childhood, hence made more neural connections in those association areas, or if you aren't looking at that piece, or if anybody's looked at that piece.
You know, I wish it were easy to do a study like that. I wish we knew that answer. And I would bet you anything that kids who are in a more enriched environment are going to end up with better brains than kids in a restricted environment.
But the really extraordinary creativity, or?
I don't know that you can, I don't know that you can necessarily produce extraordinary creativity with a very enriched environment, but if you have the correct combination of the diathesis being there and the stimulation, probably. I was told that that was supposed to be the last question, so.
Well, we thank you all very much for being here tonight, and one more thank you to Dr. Andrew